So remember, RT by omega naught L is QE, omega naught C into RT is also QE. So if you do that, you see Y is equal to 1 by RT into 1 plus J into QE into omega by omega naught minus omega naught by omega. So this is the, because in both the terms you will get QE, right? So I can take QE outside. If you do that, you will get QE into omega by omega minus omega naught by omega, the whole thing divided by RT. So this is the final simplified expression for Y. So I cannot do anything more than that. So I can find Z equal to 1 by Y, reciprocate this. So Z will be RT by 1 plus JQE into omega by omega naught minus omega naught by omega. See, omega is any frequency and omega naught is your resonant frequency of your tuned circuit. Okay, resonant frequency. This omega is a variable, but omega naught is a constant. It is the resonant frequency of a particular tuned circuit which will not change unless you change the value of L and C. Okay, and I am going to simplify this expression further. I am going to introduce one parameter called delta. So delta is called as the fractional frequency variation. How much the frequency is varying from omega naught. It is the deviation from omega naught. So delta equal to omega minus omega naught by omega naught. I am finding the deviation of the frequency from resonant frequency with respect to resonant frequency. So I am dividing by omega naught. I am not finding it with respect to any frequency. So I am finding the deviation of the resonant frequency from any frequency omega with respect to omega naught. So it is omega minus omega naught by omega naught. Divide each term omega by omega naught minus 1. So delta equal to omega by omega naught minus 1 or omega by omega naught equal to 1 plus delta. So why I am finding this, I am going to substitute this here. So omega by omega naught is 1 plus delta. Omega naught by omega is 1 by 1 plus delta. So I am going to substitute this in the expression for this. That's why I am writing the expression for delta as a fractional frequency variation expressed in terms of resonant frequency omega naught. It is also same as f minus f naught by f naught because omega is 2 pi into f. So either you can write it in terms of omega angular frequency or in terms of normal frequency f. So substitute wherever you have omega by omega naught, put 1 plus delta. Wherever you have omega naught by omega, you put 1 by 1 plus delta. It is reciprocal of that. See here, Z equal to RT by 1 plus JQE into 1 plus delta minus 1 by 1 plus delta. So take LCM inside the square bracket, expand all the terms. So you will get 1 plus delta square plus 2 delta minus 1. This 1 and 1 will get cancelled, divided by 1 plus delta. So I am taking 2 delta outside as common from the numerator of the bracket. So if I take 2 delta as common, you will get 1 plus delta by 2 divided by 1 plus delta. You know delta is a deviation from the frequency and the value of delta will be very, very close, very, very small. It will be very, very small when compared to 1. So I can, in this term, numerator will become approximately equal to 1. Denominator will become approximately equal to 1. So this entire term will become equal to 1 because delta is very, very small when compared to